Alright, you're filming.
We're on!
Hey.
Alright, so we continue with our equilibriums. I do hope that you try to find some type of natural equilibrium that's set up out there, but here's the thing you do have to understand, the rates are equal, but that doesn't mean that the concentrations are necessarily equal. You have to know it's equal at equilibrium in chemical equilibriums, and that is the rate of the reaction. Okay? So it looks like from the outside looking in, it looks like the reaction is stopped, but it has not stopped. So get this note. There's a glare.
All I see is
I think that's looking down.
yeah. Oh. Thank you.
Hopefully that gets rid of some of the glare.
Can you move your elbow? Thank you, good friend.
Yeah, good friend. A good friend.
Where are the camera do this? No, you know his address.
Whose address? Bradley's or Leslie? Bradley's. Oh, better. Say go. So better.
I agree, Sam. So much we do.
So right now you've just written down a bunch of words. What I'd like you to do at this time is to actually read these two notes that are starred. One is starred and one is double starred. I want you to read them, and then I have a couple questions for you.
Can you read your handwriting, Brad?
That's concentration.
Oh, gosh.
That's equal. This.
You can't read your own handwriting.
That was established a while. Wait, what's Bradley's phone number?
434-473-4159. You just said it.
434-473-4319.
You said it so wrong.
Why'd you say 4319?
So now that you've written them and you've read them, somebody kind of in your own words, not just reading my note again, in your own words, try to explain chemical equilibrium. And I can give you this right here. This is our famous copper wire into silver nitrate.
Why do we still own it? You should sell it.
Oh, we still have it because
Can I drink
now
it?
So it has merch.
How long?
Since
that just-
No, silver's
It
up.
looks like a
I know,
slurp
and
juice.
Doesn't it?
The
Silver's
ratio
up right
remains
now.
the
As of the
same the
recording of
entire
this video,
time.
silver's
Everything
up.
is constant.
Tomorrow may go down.
Ratio remains the same.
But it's not
Kill to death
necessarily
ratio
equal.
is always equal.
all right,
Okay,
so
slurp
kill to death ratio is always equal, so the population would not change.
Sure,
Yeah,
wait.
it's like
Kill to
Or the law.
birth.
It's like humans. Death.
Death to birth.
Well, isn't there like
This is
1,000 people born every second?
So even in your very strange way, I think that the population idea is a good one. So if death rate and birth rate are the same, the population will stay the same. So in other words, just as silver ions are becoming silver metal, copper ions are becoming copper metal. And that is just happening. That's why this looks like it's not changing at all. Now, what we find out in this single replacement reaction is that it favors the silver. silver will replace copper. That's why we have silver being made here. But there's a very good chance that this has reached a chemical equilibrium. Why? Because it doesn't appear that anything is changing at all. Just like our cobalt chloride last week, if I put it in those 3 different environments, we had 3 different colors. And those colors didn't really change once they were in those environments, unless I did what? Switch the environments all on. Then we would get one at room temperature, we'd get one in the cold temperature, and we'd get one at the warm temperature, and we would have a different equilibrium. So the equilibrium is temperature dependent, we're seeing that, but what is equal is the rates, not really the concentrations. But even though we know the reaction is continually going on behind the scenes, it is really pretty much done. Yes, Julia?
Sorry, just put my hand up.
She put your hand up? Yes, Sophia?
I'm looking at her nails.
Oh, you were looking at her nails.
Because you did them. Yeah.
Excellent.
Wow.
How was on film?
I want to see her nails. Let me see.
I thought for 1 second we were going to have a question.
You're
So
pushing
what
it a
is
little.
equal is the rates of the competing reactions. That's what it is. Just as a forward reaction is making product, the reverse reaction is making the reactant back again. That brings us to a law of nature. Hey! So yes, this is like the law of gravity. This is like the law of conservation of energy and the law of conservation of mass. These other laws that we've discussed.
Do you have a biscuit?
No, we don't. And the law of chemical equilibrium states that every reversible reaction, doesn't matter. I know in theory all reactions are reversible, just not in practice because we're on Earth. But every reversible reaction, even on Earth, will reach a state of chemical equilibrium, described by KEQ. Now, KEQ is just a symbol.
What is KEQ?
Just a symbol. Some textbooks will just put a K.
What does
I
it
put
say?
3. Some even put
It's just, it will describe the equilibrium. I will show you.
Just K is annoying
Said the
though,
same
'cause then
thing,
you're on a different.
Calvin.
Actually, I think, now, here's how I learned it, KEQ,
That makes sense.
but I get how K can just be used. I think the textbook that Compass bought,
probably uses 3.
I
Does
I
exist?
think they use K.
Probably
It does exist,
So why don't we have them?
and I don't know what your, they just got them. This is for next year's class.
It's always for next year. Oh my.
I don't know, I think for maybe your parents, it might be an advantage,
What?
but I think for students.
Do we not have to take notes?
Guys,
Well,
No, we
you
already
have
have
to
a
carry it
textbook,
to
right?
With them every single day.
I'm just assuming I'll be back.
No.
We're making
way.
our own textbook, Oliver.
I don't know how we're gonna use it.
Planning for
If
the
you
future.
use the
Loser,
textbook
I get
like
to
it's
get
supposed
outta
to be
here.
used, They're gonna have to carry that thing.
Don't think that's a good
Get
thing.
out of
It is very big.
Yeah.
You might have to do chemistry.
I do get to do chemistry.
And they're expensive, so if a student were to destroy or lose one, they would cost more money.
Why would they destroy or lose one?
We that bored?
It's a giant.
How about
book.
this? Are we gonna hand in our little notebooks? I forgot what our little notebooks.
Oh, those things, the yellow
I read
ones.
through that one.
I have.
So it's somewhere.
I actually have not touched
How about you
mine.
just take it now?
I think it might still be in my backpack. I don't think I ever took it
Oh
out.
gosh, this
I
is what I mean by
definitely-
destroy.
We got to put
My backpack.
Yeah, we did.
Fine.
Wait, I feel like those are kind of.
It's somewhere in my house. I know it exists, but
It's literally at my desk.
Settle down. No, they're not too bad.
What are we even talking about?
why are we
The
always
little
at
notebook
for next year?
Oh, I
It's
know.
yellow.
It's yellow. It has a purpose.
But look,
Dummy's guide.
quiet down.
I know.
Of course, some of you guys don't open your real notebooks up.
That is not completely true.
Hey, that's not totally true.
Low blow, low blow.
That is not totally true.
Yeah.
So let's see what this. Let's see
I
what
have
this
a
text
medical
uses.
disability.
I have
It's called
IBS.
ADD.
Mine's still in my bag.
Brand new.
Acids and
Had to
bases.
touch more open.
It's like I open it and I'm
Dude, one of
like,
those was
Quiet down. You guys are too loud. They use.
Why are we always the test subjects for next year?
drum
No,
roll.
no. You gotta remember, they use just K.
Guys, the
Drum roll.
11th graders are that subject.
Yeah.
No, we're not.
So 11th graders they got these like midway through the year.
What do we get test subjects for so much stuff? We
They
need
use
11th
K?
grade.
Again, I think it might help some parents out. I don't know, and I guess we'll use them because we have them, but
We've always been the test subjects.
it's just gonna cause your book bags to be heavier.
It means they don't have to take notes in class, right?
No, they absolutely have to take it.
Well, then that just defeats the purpose entirely.
So what's the point of a textbook?
Because, look, the amount of material in a textbook is there's no way that I could cover that in a single year. So this is what gets covered.
Oh yeah.
Alright, so K or KEQ, either one is an acceptable, and it does equal the chemical equilibrium. It describes the law. And here's how you calculate.
This is a paperweight.
Here's how you will calculate a chemical equilibrium.
6,740 moles.
So the equilibrium position is the concentrations of the reactants and products when they're at equilibrium. That makes sense.
Pardon?
Preston threw that at my head.
Let's not throw
That's
items
yours.
in class.
Yeah, and you threw it at me.
Keep throwing me first.
I gave it to you.
No.
Oh, it was like
It was cherry cobbler that
Yeah.
got smushed by all my Capri Suns.
you gotta wash it down somehow.
And then there is a starred note at the bottom. And it says that pure solids and liquids are left out of the equilibrium equation. A lot of chit chat in this corner.
I was asking.
So let's take a quick look at our cobalt chloride solution.
No. That was not a table. Can I keep these?
No.
Oh. I'm gonna keep them.
So our cobalt chloride solution, how much of these ionized cobalt ions will be in solution depends on the temperature of that solution. Again, this is what we saw right in front of our very eyes on Wednesday. And so what do we do with this, and what do all these symbols mean? Well, we know what the symbols mean if we remember our notes from lecture, I think it's 4. We don't remember our notes from lecture 4. I'm not going to pretend. So let's
Notes
get
do well.
all of our symbols because they're going to be important here. AQ is the one that's on the board right now. There's also an S, there's also an L, and there's also a G. These symbols are what's going to appear in balanced chemical equations, especially for equilibriums. Let's go with the easy ones. What do you think an
Solid,
S?
liquid, gas.
Yes. This one is solid. This one is liquid. This one is gas. Does anybody remember what the AQ was? Well, it wasn't plasma.
It's like,
Pressure.
It means in solution, and the word that something is in solution is called aqueous.
I remember
I knew
that.
that.
Well, duh. I mean, come on. Everyone knows that.
Yeah, just right.
No. Does it say worm?
No, that's equilibrium.
Equilibrium? Equilibrium?
Hey, don't, Bradley, try to take good notes.
I'll
Because if
try my
Oliver's
best.
laughing at you, that's not good.
I'll try my best.
Mine are like pretty good. I mean,
I do like hits, that's not, those are better. So that's what I'm talking
Look
about.
at mine. Mine are cursive.
Bradley's looking up at me while he's writing. That's not good. Focus. Focus on the notebook. Nice and neat handwriting.
I don't.
That's not possible for
What
me.
is the neatest you
Bradley?
What's
Ow!
the neatest you could write?
If I take,
Work really hard
okay.
right now.
Send it to the principal's office.
Did you hit a teacher? Oh my goodness.
Brother,
I
that's the
saw
neatest you could write.
For whatever reason, we like states I walk.
Alright, so this makes, listen up. Which is aqueous. Aqueous. A-Q-U-E-O-U-S.
You're coming along. You know what? During the sleepover, we're not gonna do anything until you can write good.
We're gonna be
Alright,
here
so
for
this is good. This is not bad for you guys. It's pretty good for you guys. Here's what we're gonna find out. Pure solids and liquids are left out of the equilibrium expression. Now you don't know what an equilibrium expression is yet, so it doesn't make a lot of sense to you yet, but it does tell you this, that if it is a solid or liquid, you don't need to have that part of it in there, okay? And there's gonna be a good reason for that. Can somebody tell me
Yes, dear.
what a concentration really means when it comes to like math?
Juice.
Like what is, yeah,
Where you
juice
put
is-
the juice in the.
Now, shift that to math though.
concentration.
Very good.
Bradley concentrating on his anger.
Bianca is correct. This means these are proportions. All right? So that means they're parts of something or percentages of something. Here's a for instance.
these are.
We just were talking about that. Math.
That's how
We
big
have
tech.
Beautiful.
Shout out tech.
Why are they so big?
Oh my.
I've seen bigger. That's not gonna fit in my backpack.
Yeah, where am I gonna put that?
I don't
Why did get one?
Since we got them in about a week and a half ago, if your parent has requested a textbook, that is why you get one. Enjoy.
Chatty does a very good job.
Notebook Ellen does.
Hey, look, I'm all for it.
Notebook 11 makes a great textbook.
That's what I'm saying.
Just make sure they come back to the school. All right, needless to say, she was right. It is a percentage. It's the amount. It's a proportion. And here's why pure solids and liquids won't be included. Well, because they're pure solids and liquids. If I have 2 grams of salt in my hand, 2 grams of salt, all right, what percentage of salt do I have in my hand? 100%. But wait, what if I take half of that away
50%.
and I have 1 gram of salt in my hand? It's still 100% salt. It's less of it, but it's still percentage-wise 100% salt. That's why pure solids and liquids are left out of this expression, because they are not proportions. Why is there talking still from here and from there? Stop talking. Oh my gosh.
Oh
Just
no.
The audacity.
All right. So, you need the things that are going to be in percentages. And we know from our gas laws that gases, they form percentages of their mixtures. We know that the air we breathe is 80% roughly nitrogen, 19% roughly oxygen, and a bunch of other little gases in there. So we know that they do form percentages. And of course, aqueous solutions, you dissolve an amount, you make a molarity, you make a concentration. So these two right here, aqueous solutions and gases, they must be included in your equilibrium expression. Whereas solids and liquids, you don't have to worry about it.
Their mother, like, don't
So that's good. So now how do I make one of these? All right, well, here's how you do a KEQ. A KEQ or a K is equal to the reactants, the products, concentrations, raised to the power of their coefficients. Over the reactants concentrations raised to the power of their coefficients. All right, so in other words, let's do the, do you remember the, if you studied your notes, you would remember the general formula I gave you.
N equals N over L.
So it was, no, that's molarity formula.
Oh.
The general formula
Okay.
was this.
Oh, and then it's like, it's the
It's the alphabet.
B.
With the reversible arrow. And so now, with this idea, products raised to the power of their coefficients divided by reactants raised to the power of their coefficients, who can tell me the formula for K that will describe a reaction at equilibrium using this general formula? Who can just walk me through it? It's a quotient, by the way. Somebody. Walk me through it. It's going to be products over reactants.
KEQ.
So K is going to equal what? If this is the equation.
Jack's dog here.
That's my today phone.
Where does that go then?
All of that?
A wouldn't go on the top.
Then I have
You're close though,
good attempt.
because the reactants go on the bottom.
Oh.
Better.
But they're both
Oh, so A and B are at the bottom, and then C and D are at the top.
Everything.
Now be careful here, because this is the common mistake. Listen up. This is the common mistake in high school. It is
trust me.
A raised to the power of its coefficient, but this is a quotient. It is not addition. There's no addition and subtraction here, so this is multiplication times B concentration raised to the power of its coefficient. And then the products go on the top. C raised to the power of C. Again, it is not addition. Don't bring that. Remember, that's not math. In chemical equations, that means this and this react to form this and this. So those pluses aren't math. This is a quotient. D concentration D. This is the formula that will describe chemical equilibrium.
Whoa.
Crazy.
That sounds so big. Wait,
And we're going to be using this quite extensively because when we get into acids and bases, there's constants called Kas and Kbs. It's the same thing then. Well, Elijah,
Can I go to the bathroom?
I'm certain you probably can.
May I go to the bathroom?
Sure.
Thank you.
Matt.
We share a brain cell. Can I go with you?
Yes. Matt.
I can.
Every time I get a hand up, I get so eager. I'm thinking I'm going to get a chemistry question.
That's funny.
Do you want one?
Yes.
Do you want one? What about a God question? Would you answer?
There might be time for that, but not right now.
There's always time.
There's always time.
There's always time for God.
Equation for going to the bathroom.
Oh, jeez.
There's gotta be.
If you could solve this equation, you could do it.
All right, let's see.
oh no.
I'm going to use polonium. That's PO.
Uh-huh.
Thank you for explaining that question.
Oxygen.
Plus.
Triangles! Delta T is back.
Can we do chromium?
Oh,
Delta T is back.
no. We'll get to Le Chatelier's principles tomorrow.
Lashat, what?
I don't want to fuck that. It's like a black
Jack.
Silence! What time is it?
Oh, like 9.
10,
It's time to go. I made that up.
9:01? Alright, I think we're good for today. We have not applied this yet on any math. We'll do that tomorrow.
Free time?
Now can we answer questions
It is
about
not
God?
close to free time.
Wow.
But we can stop this.
It's gonna be such a good day.